Ask yourself a simple question. What is the world made of? Today, we've got answers like atoms and the periodic table, but for almost 2,000 years, the answer was much simpler, and it was considered absolute truth. So absolute, in fact, that just questioning it could get you thrown in prison. And that's the story we're going to unpack.
Okay, picture this. It's 1624. We're in Paris, and a chemist named Etienne de Clave gets arrested. The charge? Heresy. So you have to wonder, what on earth did he do?
Now, your first thought might be, okay, it must have been something political, or maybe he said something that went against the Bible. But no, it wasn't treason, and it wasn't blasphemy. He wasn't even questioning our place in the cosmos like Galileo was around that same time. So what could have possibly been so dangerous? Believe it or not, his crime was all about chemistry. He had simply planned a public debate to challenge the official accepted theory of what the world was made of. And for the powers that be, that was an act that just could not be tolerated. So let's get into it. Who was this man, Etienne de Clave? And what was this so-called heretical idea that got him into so much trouble? Here's the deal. De Clave's big crime was daring to contradict the accepted system of the elements. And this wasn't just any old system. It came from the ancient Greeks, and most importantly, it had the official stamp of approval from the big man himself, Aristotle. By the 17th century, Aristotle's ideas weren't just philosophy. They were completely fused with the authority of the church and the state. So, if you questioned Aristotle, you were questioning the entire social order. That's why his debate was shut down by a parliamentary order, and he was promptly arrested. Which, of course, brings us to the real mystery here. What was this idea? What theory of the universe was so powerful that even just debating it was considered a literal crime?
All right, let's pull back the curtain on the law that de Clave dared to break. We're talking about Aristotle's incredibly long-lasting theory of the four elements.
You know, this idea didn't just appear out of nowhere. It had a serious pedigree. It all started way back in the 5th century BC with a Greek philosopher named Empedocles. He's the one who proposed that everything was made of just four basic things: earth, air, fire, and water. The idea got picked up by the great Plato, and then his student Aristotle refined it. And it was Aristotle's endorsement that really gave this theory the intellectual horsepower to dominate Western thought for nearly 2,000 years. So how did this whole system actually work? Well, for Aristotle, each element was defined by a couple of qualities. Fire was hot and dry, water was the opposite, cold and wet, air was hot and wet, and earth was cold and dry. And here's the really clever part. Because they shared these qualities, you could supposedly transform one into another. If you took water, which is wet, and just changed that quality to dry, boom, you got earth. It was an elegant system that really seemed to explain how everything in the world was always changing. But then, after the Roman Empire fell, everything became much more rigid. In the medieval West, people clung to the wisdom of the ancient world, and Aristotle's philosophy got woven directly into Christian doctrine. So his words weren't just scientific theories anymore. They were seen as reflecting God's own perfect design. For over 1,000 years, questioning Aristotle was basically blasphemy. It was really about power and preserving the status quo. But you know, even a theory that's backed by both God and the state can't explain everything, and eventually cracks began to appear in this one. The folks who tried to patch the holes? The alchemists.
The biggest problem, by far, was metals. I mean, think about it. Gold, silver, lead, iron, they're all incredibly different from each other. But in the Aristotelian system, they would all just lumped together as different kinds of earth. And that's obviously not a very useful explanation if you're actually trying to work with them. A better system was needed.
So the alchemists started adding new layers to the theory. They kept the four classical elements, but for metals, they added two principles: sulfur, which is thought to represent combustibility, and mercury, which represented metallic properties. The idea was that different combinations of these two made up all the different metals. Later, a third principle, salt, was added to explain solidity and living things. They were trying to make the old theory work, but it was just getting more and more complicated. And all this patching and fixing brings us to the man who decided that trying to fix the old rulebook just wasn't enough. It was time to write a completely new one. So, in 1661, about 37 years after de Clave's arrest, the Irish scientist Robert Boyle published a landmark book, The Sceptical Chymist, and his main argument was nothing short of an earthquake for the scientific world. He argued that we can't figure out what elements are just by thinking about them. We have to test them. We have to do experiments. This was a massive change in thinking. The old way was all about authority and philosophy. You started with the answer, whatever Aristotle said, and if your observations disagreed, then your observations must be wrong. But Boyle's new way was all about experiment and proof. You search for an answer, and if your theory contradicts the experiment, well then your theory is wrong.
Boyle then proposed a new, practical definition of an element. It wasn't about being hot or cold or wet or dry. The key takeaway was revolutionary. An element is a basic substance that cannot be broken down into anything simpler. It's the fundamental ingredient, and you find it by trying to break things apart in a laboratory, not by reading about it in some ancient book.
This shift from just thinking about the world to actually experimenting on it didn't just give us a new definition, it blew the doors clean off our understanding of the universe. Let's take a look at just how profound that change really was.
For nearly 2,000 years, the smartest people in the world believed that everything, you, me, the stars, the rocks, was made of just 4 fundamental things. 4.
But thanks to Robert Boyle's new experimental method, we now know that there aren't 4 elements. There are about 92 that occur naturally, with even more that have been created in labs.
This whole journey wasn't just about correcting a number. It was a complete transformation in how we gain knowledge. It's the foundation of modern chemistry and pretty much all of modern science. We went from 4 poetic ideas to the detailed, predictive power of the periodic table.
You know, the ancient elements, earth, air, fire, water, they had a kind of poetry to them, a real connection to human experience. Today, our understanding of matter is far more accurate and powerful. But it makes you wonder, as we gained all this incredible chemical knowledge, did we maybe lose some of that older, more imaginative connection to the world around us?